We are taking a look at a dataset that analyzes the success of bank telemarketing provided by Satoshito Tomoto through Kaggle to predict if a bank client will subscribe to a term deposit. The dataset has 45,210 rows, and as you can see, the first column index will not be necessary to build our model. Let's jump over to terminal to run Brainome. First, we'll run the command -h in order to see all the possible commands we have while running Brainome. For this dataset, we will use -ignore columns, -f, -e, and -split. For our first run, we will just run Brainome in AutoML mode to analyze the data. We will immediately ignore the column index by using the command ignore columns. By running in AutoML mode, we can compare 4 types of models and then use this information to later force the model to be the one we prefer. You get some initial statistics on your data. We can see the number of records, and we see this is an unbalanced data set. The table at the bottom reflects the training and validation accuracy of all models: random forest, neural network, decision tree, support vector machine. The one highlighted with a star gives the preferred model for this configuration, which gives a validation accuracy of 90.56%. The random forest model's training accuracy and validation accuracy are both above the best guess accuracy, making it the best model for this dataset. Brainome automatically splits your data into training and validation set. In this particular case, it is split half and half. Later, we can improve on the split by using the command -split. You can follow along the results on the right-hand side of the video. For the second run, we are forcing the model to run random forest since it is clearly the best performing model. We are going to increase the effort using -e to 10 to increase the compute time. By using the split command 80, we're going to allocate 80% of the data for training and only 20% for validation. It is a longer run because even though we are only training one model, we increase the effort by 10. Let's take a look at the results and compare on the right side of the screen. We see a slight improvement in our results with the increase in effort and 80% split. About 1% increase in training accuracy and a little over 0.5% for validation accuracy. In our final run, we will increase even more to see if more training time makes things better. Let's try effort 50. We are speeding up this video to show you the results a little bit faster. This run took much longer, just over 8 minutes. We can see the results are varying, very slight increase in training accuracy and decrease in validation accuracy. The real question here is if more effort is actually better. We can see that the middle model is more useful. There is a tendency for people to focus just on accuracy, but as we see here, the model capacity has increased. In the last model, we have slightly lower validation accuracy, but the size of the model is much smaller, about 12%, and we get better generalization. The better model depends on your use case. If you don't expect much data drift or you will retrain frequently, go for the model with a better accuracy. If you do expect to see data drift or less frequently train, go for the more resilient model, the last model. Get started with pip install Brainome and try a dataset on your own.